Welcome to lecture 16 of the course CS213 Object Oriented Programming of the Cohort University of Science and Technology. In this lecture we will discuss abstract classes. We will have an introduction to the abstract classes and we will get into a bit of detail of the abstract classes, and we will also look at an example implementation of using abstract classes and methods. In the upcoming lectures, we will also discuss the relevant concepts like the interfaces and the comparison between the abstract classes and interfaces, how we can use the interfaces, and the final variables, methods and classes, etc. The relevant material for this lecture can be found in chapter 10 of the book Java How to Program Early Objects version, detail and detail. You can also find other tutorials online on the given links. For example, we are given some shapes, let's say a triangle, a rectangle and a circle, and we have the UML diagrams of these shapes in the form of UML class diagrams, which tell us the variables for each of these classes and the methods of these classes. If we look closely at these methods, there are some general methods that are general in each of these classes. These are the getter methods and the setter methods. And then we have some specific methods like the draw and the area. So the draw method for the rectangle should return or should draw a rectangle for us. The draw method of a triangle should draw a triangle for us, and the draw method of the circle should draw a circle for us. Similarly, the area method of the triangle should return the area of the triangle. Area method of the rectangle should return the area of the rectangle, and the area method of the circle should return the area of the circle. And if we look closely, we can see that most of these methods are very similar. The signatures of these methods are the same. As we can see, the setter methods and the getter methods, and if we look at the signatures of even the specific methods, they are all the same. So we are repeating the same kind of definitions or the same methods in each of these classes, which can be called a bad design. We are not taking advantage of some of the concepts that the object oriented programming provides us with. So we can use those concepts using the object oriented programming to improve on our design in this case. That will reduce our programming and designing effort. We can use inheritance, and in inheritance what we do is, as we have seen previously, we combine the common details of the classes into a common class that becomes the superclass, and in this case we create a shape class that is the superclass of the triangle, the square and the circle class. The shape class will include the common methods and the common variables, which in this case is the instance variable point p, and the methods set, get and translate methods. These are common to all shapes. There are specific methods, draw method and area method. Now what we can do with the draw method, or what we should do with the draw method or the area method, can we possibly implement these methods in the shape class? What if we try to implement the draw method in the shape class? And if we call the draw method of the shape class using an object of the shape class, what shape will be drawn? We have no idea because the shape in itself is not a specific object. A shape can only possibly be, in this case, a triangle, a square, or a circle. The shape, as we understand, has none of its own existence. Similarly, if we try to calculate the area of a shape, what is a shape? We cannot think of a shape independently of any of these or any other specific shapes. So if we call the area method using an object of the shape class, we are not sure if we will be calculating the area of the triangle or the square or the circle. So each of these classes need to have their own implementation of these methods. Need to draw calculate area for all shapes, but this is done differently for different shapes. So we cannot use a common method to draw these shapes, or we cannot use a common area method to calculate the area of these shapes. So what we can do is we create the triangle, the subclasses, and we can use an array of shapes as we have used in polymorphism, and we can call the draw method using the object of each class as we are trying to do over here, but invoke the draw method in the array of shapes. But how do you implement the draw or area method in the superclass? What, again, the question remains the same. What shape will be drawn if we call the draw method that has been declared in the superclass using this object that has been initialized using a reference to the superclass? It is a rectangle class object that has been declared using the superclass reference, and it has been stored in the superclass array. So it might not be appropriate to have any code for the area method in the shape class at all. Why? Because we do not know how to calculate the area of an object if we do not know the type of the shape. So we need to know the type of the shape, let's say a rectangle, to be able to calculate the area of that shape. If we do not know the type of the shape that we are trying to draw or that we are trying to calculate the area of, we will not be able to implement that method in the shape class. So this is not the right idea of writing this program. We need to change this and improve this implementation. What we can do is we can use abstract classes. That is an extension on the inheritance concept. So pure inheritance was not able to help us in our situation. The situation is given over here with the slight change. We have a shape class, that is the superclass of the circle class, the rectangle class, and a triangle class. And now we will be using the abstract class. So we have the draw method and the area method in the shape class. We have the draw method and the area method in the circle class. The draw method for the circle class will draw a circle, and the area method of the circle class will calculate the area of the circle. Similarly, we have a draw method and an area method in the rectangle class. The draw method of the rectangle class will draw a rectangle, and the area method of the rectangle class will calculate the area of the rectangle. So when we call the draw method using an object of the rectangle class, a rectangle should be drawn, and we call the area method when we call the area method using an object of the rectangle class, the area of the rectangle should be calculated and returned in the form of an integer value. Similarly, we have a draw method and an area method in the triangle class. So when we call the draw method using an object of the triangle class, a triangle needs to be drawn. And if we call the area method using an object of the triangle class, the area of the triangle should be returned in the form of a rectangle. Since we are not implementing these methods in the shape class for the reasons we mentioned in the previous slide, that we cannot possibly draw a shape when we do not know what shape we are drawing, or we cannot possibly calculate the area when we do not know what shape we are calculating the area for. But we need to implement these methods in all of the subclasses. So what we can do is we can include these methods as abstract methods in the superclass. What would happen is, or what should happen now is, the superclass should also become an abstract class. Now we will look into the abstract class in detail and the abstract methods in detail. But what we have done over here is we have turned these methods into abstract methods, and resultantly we do not need to have the implementation of these methods in the superclass now. The superclass now, when we turn these methods into abstract methods, the superclass should also be turned into abstract class. We cannot have abstract methods in a non-abstract class. Although we can have an abstract class without any abstract methods, but the reverse is not true. We can see that the shape class, the name of the shape class is written in italics in the UML class diagram of the shape class. That depicts that this is an abstract class. These names are not written in the italics because these are not abstract classes. The implementation of the abstract method is now a requirement in the subclasses. So when we extend the shape class in the rectangle class, we need to have an implementation of the abstract methods of the shape class in the rectangle class. We need to implement the area method, and we'll need to implement the shape method as well. Similarly, for the circle class, when it extends the shape class, it needs to implement the area method and the shape methods. If we do not implement these methods in the subclasses, we will get a reminder from the compiler. So we need to provide implementation for these methods in the subclasses. Now, to differentiate between the concrete and the abstract classes, we can say that a concrete class is a class that can be used to instantiate objects are called concrete classes. In simple terms, when we can declare an object of a class, that class is a concrete class. Alternatively, we can say that we cannot declare objects of the abstract classes. That is why an abstract class is an incomplete class. It's an abstract class. A concrete class can provide implementation or should provide implementations of every method they declare. Some of the implementations can be inherited. As we saw in the abstract classes, when we declared a method as abstract, we do not need to provide implementation for that method. The implementation of that method is provided in the subclass of that class. So we can say that an abstract class needs a subclass in order to implement the methods of that class. Abstract class used only as superclass in inheritance hierarchies. So an abstract class will always have a subclass. An abstract class is not complete without a subclass. Used only as superclasses in inheritance hierarchies, so they are sometimes called abstract superclasses. Cannot be used to instantiate objects, as we saw that the difference of the abstract class from a concrete class is that abstract classes cannot have objects. Abstract classes are incomplete and they specify only what is common among subclasses. In order for an abstract class to be completed, it needs to have a subclass that implements the methods that are there in the superclass or the abstract class. So we cannot declare an object for the abstract class. If we try to do this for the shape class, which in our example was an abstract class, we will get a compile error. Subclasses must declare the missing pieces to become concrete classes from which you can instantiate objects, otherwise these subclasses too will be abstract. So as we saw on the previous slide, that the subclass must implement the abstract methods of the abstract superclass. If it does not, we will get a compiler error. Alternatively, we will need to declare the subclass as abstract as well, so that it has its own subclass or subclasses that implement the methods of this abstract subclass. Abstract methods. We saw an example of the abstract methods in our previous slides. Abstract classes permit declaration of classes that define only part of an implementation, leaving the subclasses to provide the details. So what we can do is we can include the method as abstract in a superclass, and the implementation for that method will be provided by the subclass. Implementation of common state and behavior that will be inherited by the subclasses. Declaration of generic behaviors that the subclasses must implement. An abstract method shows us the common behavior that the subclasses have or must have that will be implemented by those subclasses. So for example, in our example, all the subclasses needed to have a draw method. And if we want to ensure that or make it compulsory, what we can do is we can declare those methods as abstract in the superclass. Now whenever we extend that superclass into a subclass, that subclass will always be required to implement the abstract method so that it has the same behavior as of other subclasses of this class. So if we extend the shape class further, all of the subclasses of the shape class should have an implementation for the draw method and the area method. That is now compulsory because we have made the methods as abstract methods in the shape class. We make a class abstract by declaring it with the keyword abstract, as we saw in the example that we can declare or make a class abstract by writing the abstract keyword in the declaration of that class. Public abstract class shape. An abstract class normally contains one or more abstract methods. An abstract method is an instance method with the keyword abstract in its declaration as shown below. So we simply need to add the abstract word in the declaration of the method to turn that method into an abstract method, and we do not need to implement this method. So this line completes the declaration of the abstract method. There is no body of this method in this class. Abstract methods do not provide implementations. There are some rules that we need to remember when we use the abstract classes and abstract methods. An abstract class is not required to have an abstract method in it. As I said earlier, that for an abstract method, it is compulsory that it needs to be declared in an abstract class, but the reverse is not true. We can have an abstract class without an abstract method. But a class that contains abstract methods must be an abstract class, even if that class contains some concrete or non-abstract methods. So as same was in our example, that we had some implementations in our abstract class, but then we also had some abstract method in that abstract class. So in simple terms, if we include an abstract method in a class, we must declare that class as abstract class. When a class inherits from an abstract class, it must implement every abstract member defined by the abstract class. As we saw in our example, when we had the abstract draw method and the area methods in the shape class, we needed to provide the implementation of those methods in our subclasses triangle, rectangle, and circle. Failure to implement a superclass's abstract method in a subclass is a compilation error unless the subclass is also declared as abstract. So we can do either of the two things. If we inherit from a superclass that is an abstract class, we need to implement every abstract method of that superclass, or we will need to declare the subclass as an abstract class, which will in turn have its own subclass, which will need to, and that subclass will need to implement the abstract method of its superclass. So there is no way that we can get away with the non-implementation of the abstract method in the subclasses, because without the implementation of the abstract methods of this abstract class, the abstract class will not be complete. Constructors and static methods cannot be declared abstract. So we need to remember that we cannot declare constructors and static methods as abstract. An abstract class cannot be instantiated. However, references to an abstract class can be declared. And we'll see in in our future examples that we cannot create an object of the abstract class, but we can declare variables of our abstract class. We can use it as a data type. These can hold references to objects of any concrete class derived from those abstract superclasses. As we saw in inheritance, you are able to use the superclass references to create objects for the subclasses. We will be able to do the same for the abstract classes as well. So if we look at this simple example, consider the shape, rectangle, and circle classes defined previously. Add an abstract getParameter method into the shape class. Implement the getParameter in all the subclasses. We'll look at an example in our next video. In this video, we talked about the abstract classes and some of the rules that we need to follow whenever we deal with the abstract classes. So see you in the next video for this lecture.